Welcome to the PhysicsPlace, the place to learn about physics. And in this video we are going to see how we can combine forces in the same line of action. We can also combine forces when they're not in the same line of action. That will be in my next video, but now we are looking at the same line of action. And that actually means like this: if we have two forces to the right, we have a force to the left, that's the same line of action. They don't need to be in the same direction as long as they are in the same line. Like this, they're both in the same line. And even like this, we can sort of say that they're both in the same line. They're going to the left or to the right, but nothing is going up or down, it's just left and right. So that's the same line. In this example we can see three people. This one is pulling on a rope with a force of 18 Newton and this one with 25 Newtons. And if they are working in the same direction and in the same line, then we can add them together. So these vectors acting in the same line of action can be added if in the same direction. So together we can now determine that their force is 18 plus 25 equals 43 newtons. So together they are having a force of 43 newtons. And of course, very important, to the right. Because it's a vector, it's important to know what the direction is, and in this case it's to the right. So together they are pulling with 43 newtons to the right. In this case, the plane is having a force forward and a force backward. Probably the engine forward and air resistance backward. And they are now also in the same line of action. One is going forward, the other one is going backward. So they can be subtracted if they are going in the opposite direction. So we can subtract one from the other. So 9,000 forward minus the 7,000 backward, and we now have 2,000 newtons to the right. So that's very important because it's a vector. We also have to say what the direction is. So in this case it's 2,000 newtons to the right. These combined forces are called the resultant, or the FR. So we have now engine force forward, air resistance force backwards, and together if you subtract them, then there is a resultant. Also in the previous one the resultant was 43 newtons. In this case the resultant is 2000 newtons to the right, the FR. This will be important for further on in physics. An exercise: determine the magnitude and the direction of the resulting force. In this case we have here the situation and we have a scale. So try now for yourself, also looking at the previous video how to draw forces, you should be able to come up with the answer. Determine the magnitude and the direction. So now we have to the left 8.4 centimeters. To the right we have 1.3, 1.8 and 3.1 centimeters. So we add them together because they all go to the right. And to the right it's set 6.2 centimeters, to the left 8.4. So now they are opposing each other, so we have to subtract them. The resultant will be 8.4 minus 6.2, that's 2.2 centimeters to the left. Why to the left? Because this one was larger than this one. So it's 2.2 centimeters to the left. So that's the magnitude and the direction of the resulting force. But now we also need to know how big it is, because now we only have centimeters and we need to go to Newton because it needs to go to force. Well, we know that 1 centimeter is 50 newtons, so we have to do 2.2 centimeters times 50. And we now know that it's 110 newton to the left. So the resulting force, FR, in this situation is 110 newtons to the left. So this guy is actually winning. And later on we will see what the effect of that force will be on the movement of this situation. Next exercise. We have a car, we got some information, we see some forces going backwards with the tires. We have the engine going forward, we have a scale, and we have an unknown force. The FR in the situation, so the resultant force, is 0 newtons, so there's no resultant force. Well, if we look at here, well, there needs to be some force here. Determine the length in centimeters and the direction of FA. So there is a force here, we don't know how large it is, we don't know what the direction is, we have to determine that. And determine the magnitude of FA in newtons, so we have to do something with this scale. So try for yourself if you can manage. I will now give the answer. First we will go to determine the length and the direction of FA. Well, first we have forward the 7.20 centimeters. That's the only one. And then backwards we have 1.6 and 1.6, so times 2 is 3.2 centimeters. And it says here in the question that the FR, the resultant, should be 0. So this one should be equal to this one. And it's not at this moment. We see that we are missing some centimeters here. To see exactly how many we have to determine FA, 7 minus 3.2 is 3.8. So we are missing 3.8 centimeters here. And it's going to the left because they are both going to left and they need to be added somewhere. So that looks like this. So now we know the length in centimeters and the direction. So it's actually 3.8 centimeters to the left. Very important that we also say the direction. Now we can determine the magnitude. We know that 1 centimeter is 150 Newton. This is 3.8 centimeters, so we do 3.8 times 150, so that's 570 newtons to the left. Again, very important, because it's a vector, we need to know the direction, and that's to the left. And now all the forces are together. If we add these three, we subtract this one, then we have 0 newtons, just like I said in the question. That's it. I now hope you know how to add and subtract forces in the same line of action. If you found this video helpful, please like to let me know, and of course subscribe for more videos. Thanks for watching.